Alright class, this is a crash course on correlational research. Very different from experiments where we have an independent variable that we can manipulate and we can measure the dependent variable, we can pinpoint causes. One of the things about correlational research is that we can't demonstrate cause and effect relationships, but we can look for patterns or trends in data, and that's really what a correlation is. It's a trend or relationship between two variables. So, for example, is there a correlation between outdoor temperature and stocking cap or hood use? I would say yes. I think there's a trend or a correlation there. When temperatures get cold, people tend to wear more stocking caps and hoods. And when temperatures are warm, people wear fewer stocking caps and hoods. So there's a correlation there. Sometimes we can't do experiments because it would be impractical or even sometimes unethical. So, well, for example, let's say we wanted to know if there was a correlation between college students' self-esteem and GPA. We can't manipulate either one of those as an independent variable because you can't just assign students a GPA and see what effect that has on their self-esteem. You also can't assign students self-esteem, like give some students high self-esteem and give some of them low self-esteem to see if it affects their GPA. So what we can do though is just measure students' self-esteem, and we can examine or look at their GPAs and see if there's a trend or a correlation between them. So generally correlations fall into one of two categories. It's either a positive correlation or a negative correlation, or sometimes actually a third category would be no correlation. But a positive correlation just means that when the value of one variable is high, the value of the other variable is high. And if you look at the example down here, positive correlation between years of education and annual income in thousands of dollars. And it's true, when the values of education are high, like you see my cursor there, these are all high values of education, and they all go right down here to high values of dollars. And likewise, low values of education are correlated with low values of income. So that's a positive correlation. Positive correlations, if you were to plot the data, will always slope upward towards the right. Negative correlation just means that when the value of one variable is high, the value of the other variable tends to be low. So we see in this example high values of dental problems. See these dots up here are all related to high values of dental problems, and they are also correlated with low values of income in thousands of dollars. So what we could say here is basically people who have more dental problems tend to have a lower income. So more dental problems correlated with lower income. And so sometimes, as I mentioned, there's also no correlation. If you were to plot the data for no correlation, it's just kind of all over the place, doesn't really have a pattern. So positive correlations slope upward to the right, negative correlations slope downward to the right, and zero correlations don't really have a slope or a pattern, they're just kind of all over the place. So let's see if you can do this. Indicate whether each of the following statements describes a positive correlation or negative correlation. The more children and youth used, the more children and youth used various media, the less happy they were with their lives, based on a study from 2010. Would it be a positive correlation or a negative correlation? That's right, it's a negative correlation. When media use is high, happiness was low. And you can flip that around too and say, well, when media use was low, happiness was higher. That's right. Well, still negative correlation either way you say it. When the value of one variable was high, the value of the other was low. The more sexual content teens saw on TV, the more likely they were to have sex. This is from a 2004 study. Positive or negative correlation? Positive correlation. When sex viewing is high, sexual behavior was high. You could also reverse that. Say when sex viewing was low, sexual behavior was low. That's what they found as a positive correlation. When the value of one variable is high, the other one's high. When the value of one variable is low, the other one's low. Positive correlation. The longer children were breastfed, the greater their later academic achievement was. So, positive. When breastfeeding length is high, academic achievement was high. Positive correlation. And you could also say children who were breastfed for less time tended to have lower academic achievement. Still positive because both variables are high together or they're both low together. The more income rose among a sample of poor families, the fewer symptoms of mental illness their children experienced. So more, higher income, for example, is correlated with fewer or less symptoms. One's high, one's low. That means this is a negative correlation. When income was higher, mental illness among children was lower. And it would go without saying that when among families who had lower income, mental illness was higher. Either way, both variables are opposites of each other in terms of their value. When one's high, the other one's low. That makes it a negative correlation. When we plot data from a correlation, we call it a scatter plot. There are examples on this screen of different types of correlations. That's all scatter plot is. When we plot the data, we can kind of tell then if it's a positive or negative correlation or no correlation based on the shape of the scatter plot. So I'm going to do an example here. All right, let's just say we were doing a study on GPA and self-esteem. We asked students to complete a self-esteem inventory, and that gave us a score, produced a self-esteem score. And I'm going to take the data from each student and I'm going to plot it here. So let's say I have a student number 1 had a self-esteem of 22 and a GPA of 3.1. So 22 and 3.1, I'm putting a little dot for that student right there. Next student I look at, the data says 12 and 2.0. Next student has a self-esteem of 18 and they have a 3.5 GPA, so that's right about there. And I'm just gonna go through the data and plot the data for all my students in this study, and lo and behold, you notice the pattern emerging. And there is the scatter plot. And you'll notice that it's sloping upward to the right. If I put a circle around that, you can kind of see that a little more clearly maybe. Sloping upward to the right, which is a sign that it's a positive correlation. We can verify that by looking at scatter plots up here, for example. Those are high values of GPA. All of these plots over here are high values of GPA. And they're all correlated with high values of self-esteem. And low values of GPA, like this student here, these students all have low GPAs. And they all have low values of self-esteem. So definitely a positive correlation. All right. So sometimes correlations are spread out a little bit, but have a vague shape to them. This would still be considered a positive correlation because it's still upward sloping to the right. I'll circle that so you can see a little bit better. All right, but the pattern's not very tight. It's still a positive correlation. We would say it's kind of a weak correlation though, as opposed to the previous one, which appeared to be quite a bit stronger. So we can look at the scatter plot. If the pattern is tight, or narrow, we know it's a strong correlation. If it's spread out, it's a weaker correlation. We can also compute a correlation coefficient, which you don't have to know how to do, but you would use a formula and compute all your data through a formula that would produce a numerical value. That numerical value might be something like this, where r equals plus 0.37. Now the plus sign means that it's a positive correlation. This number tells us if it's strong or weak or moderate in strength. It tells us how tight the scatter plot would look. And the way this works is any number close to 0 would be considered weak. Any number close to 1 would be really strong. And this is a positive correlation, so we know that the scatter plot is upward sloping to the right. It means values of both variables are high together or low together. And because it's 0.37, it's close to 0 as opposed to 1.0, which would be the highest positive correlation. That means that this is kind of a weak correlation. If it was 0.5, so if it was plus 0.5, look at that, nice handwriting with the mouse, very nice. That would be a moderate correlation. Anything like plus 0.75 or higher, I'm not very good with that. Plus 0.75 or higher is getting pretty close to 1, so that would be a pretty strong correlation. And the same thing would hold true for negative values. So look at this, can go all the way to negative 1 too as well. So a negative 0.50 would be a moderate negative correlation. Negative 0.75 would be a strong negative correlation. Right? So the sign doesn't have anything to do with the strength of the correlation. That's just telling you if it's negative or positive. It's really the number itself that we're interested in when we're looking at the strength of the correlation. The closer it is to negative 1, the stronger it is. The closer it is to 1, the stronger it is. Right? This number here, negative 0.75 and plus 0.75, have the same strength. They're no different in terms of their strength. The only difference is that one is indicating a negative relationship and the other is indicating a positive relationship, but they're the same strength. So if we were to look at this timeline, or this number line, positive 0.50 would end up being somewhere in here. The scatter plot for that would look kind of spread out. Negative 0.5. Scatter plot would be on this side because it's a negative correlation. That would be kind of spread out just like the other one, except downward sloping to the right. 0 correlation. Anything near 0 is not really recognizable as any particular pattern, so it's just kind of all over the place. Negative 0.90 is really close to this endpoint. But I have no idea why that other line, why are those lines appearing? I have no idea. Alright. This would be a really tight pattern, downward sloping to the right, with very little room between the dots. Positive 0.9 would look the same way. I don't know why those extra lines are appearing all of a sudden, but be a very tight pattern, upward sloping to the right. Alright, so let me get out of my little pointer mode here. Alright, there we go. So, if you look at the different types of scatter plots. Alright, so if I put the mouse here, it's at